Okay, so in this video we're going to do a couple of things. First of all, we've got our grid and we've got it filled with these cell objects. And so what I want to do is I want to think of each of these guys with kind of a starting point up here and a goal down here. And this is goal-based pathfinding. And so what we're going to do is, first of all, I'm going to make one modification where if I click on a particular cell, it's going to toggle it back and forth between occupied and unoccupied. That way I can create all kinds of interesting patterns and test my program to see how my enemies pass through this maze. But in any case, to get beyond that, I need to, first of all, for any given cell, I need to think about it having 4 neighbors. And so first of all, I'm going to choose those 4 guys around it. So this guy has 1, 2, 3, 4 neighbors. And in the cell object, I'm going to create an array of cell objects which represent the neighbors of that cell. Now, not every cell is going to have 4 neighbors. For instance, this guy up here is only going to have 2 neighbors. I'm only doing north, south, east, and west. Of course, you could do diagonals as well. But in any case, just for the sake of simplicity, I'll do north, south, east, and west. And I also don't want to take any cell neighbors. I don't want to make neighbors where there is something that's occupied. So this guy's going to have, for instance, 1, 2, 3 neighbors. And the reason I'm doing that is that ultimately what I want to do is I want to be able to assign these guys values. And so essentially what I'm going to be doing is assigning the the goal value 0, and then I'm going to go to its neighbors and I'll assign its neighbors 1. And then I'll go to those 2 guys and I'll assign their neighbors 1 as well. It's a little bit more complicated than this, but I'm going to create what's called a number field. And so this guy's going to get 2 and so forth. And so I'm going to go to this guy and its neighbor is going to get 3. I'm not going to change that guy because it already has a value. I'm going to go over to this guy. That's going to get 3. This guy's going to get 3. This guy's going to get 4. This guy's going to get 5. This guy's going to get 4 and so forth. And so when I am done with this, starting from this end, if an enemy comes out here, it's going to follow the path represented by the smallest number. So in this case, it's going to go for one of these 2 9s, and if it chooses to go this way, I know that this direction is actually going to be just as short as this direction. But let's say I go from 9 to 8 to 7 to 6 to 5 to 4 to 3 to 2 to 1, and I can find my way back to 0. And if there's a shortest path, this will find that shortest path. So the first thing I'm going to do is look for handle canvas mouse click. That's what I named the callback function. When I click on the canvas will, this event will be given. And right now I've already got a little bit of code in here, but I'm going to go ahead and first of all find the mouse X and the mouse Y. And so to do that, I create my own variable mouse X and mouse Y, and I use event.offsetX and offset Y. And so that's within the canvas. There's also a client X and a client Y. That's for the X and Y position of the mouse within the overall document. And so anyway, offset X and offset Y are what I'm looking for here. And so once I have that, I need to convert these back into values so I can find out which I and J value or column row value references a particular cell. Okay, now to do that, I need to come in here and I need to go ahead and convert it back. And so to do that, let me move this over a bit. And if I come in here, I've got grid column and grid row, just local variables again. And I'm taking the mouse X and I'm dividing that by the TowerGame cell width. So for instance, if this was 50 and this guy was 400, that would tell me that I'm at which column I'm in according to the grid and which row I'm in according to the grid. I need to know that to determine which cell to toggle the occupied on and off. So the next thing isn't really necessary, but I think what I'll do in here is I will go ahead and create another local variable called cell. It'll just make my code a little cleaner. I guess I got in the habit of doing this. It's not necessary, but I'm going into the TowerGame. I'm going into the grid in the TowerGame. So this is my global object. This is the grid property inside of that object. And I've calculated grid column here, so that's going in here, and grid row here. So I find out where the mouse is, I convert that into the column and row value, and then I'm taking that number from the grid. And so now all I have to do is go into cell, and I can say cell.occupied, and I just need to toggle that. So that's going to be equal to not cell.occupied. And so if, occupied. And so if, for instance, this is true, I'm going to say true is equal to not true. And if this is false, I'm going to say false is equal to not false. Not false is true. So whatever this is, this line of code will toggle it back and forth. Let's go ahead and see if this works. Okay, so I've got my grid of cells, I've got the ID number showing, I've got some random cells occupied. Every time they're occupied, they change shape, and if I click on this, that is not working. Okay, let's go back and take a look and see if we can figure out why. First of all, I've got cell occupied equals, oh, I misspelled cell. Okay, so there we go. I'm going to save that. I'll come back over here and I'll reload this, and now, yeah, that works. Okay, good. So now I can create all kinds of different sort of random obstacles for these guys to, or not random, but you know, specific paths. So when I'm testing this, I'll want to make sure that the enemies are going to find their way no matter what. And for some reason, my kids spend a lot of time playing around with this, so apparently it's fun. And let's just go ahead and let you guys have that. So when I start my enemies here, no matter how I set up these obstacles, they will be able to find their way around all of these obstacles and get to the goal cell. Okay, let's go ahead and get started on the next step. Is going to be for each cell, I'm going to do a method which is going to load its neighbors. So let's do that next. Okay, so this next step really has two pieces. I need to go back up into where I've loaded all my grid elements, and as I load my load my grid, the next thing, I've loaded my grid elements here, and I have to completely load the grid before I do this next step, because if I start looking for my neighbors before the grid is completely loaded, obviously I'm going to run into problems. And so what I'll do here is I'm going to create a nested loop, and I'm going to say after the cells are loaded into the grid, let's go ahead and take a for loop, and we'll go through all of the columns, and within each of the columns we'll go through all of the row elements, and all I'm going to do is say this dot grid column row dot load neighbors. And so load neighbors is going to be a function. This is a cell object. Each of the elements in this grid is a cell, so when I go to this dot grid CR, that's a cell object, and so I'm going to have a cell a method called load neighbors. So that needs to go into the cell class. So I need to put that guy over here, and so I'll create that method next. And I've got only render in here right now, so I need to create a new method, and I'm going to say load neighbors, and I need to go north, east, south, and west. And so to do this, I need to look at an individual cell. This individual cell has an I and a j value here, and I've loaded that in. Oh, actually I haven't loaded that in. I wonder if I need to. Maybe for the sake of simplicity, I'm going to say this dot c is equal to I. Actually, I should have named this C and R. Anyways, this is C, and we'll do this dot R is equal to J, and so I can use these down in this function. Here I just used I and J in terms of finding the location for the location vector, but in any case down here I'm going to use those. I'm going to find 4 cases. Alright, so let's just think about the math behind this for a moment. If I have these represent the columns, so this is 0 and this is column 0, and this is 0 here, and this is going to be representing row 0. And so I'm looking at the column first and then the row. And so let's say, for instance, I want to look at this cell. It's going to have the location, column is 1 and row is 1. Column is 1, that's this guy. Row is 1, that's this guy. And so what is the value of this going to be? Well, this is going to be in terms of row and, in terms of column and row, this guy is going to be same column, but the row is going to be row minus 1. And this guy's going to be the same column, and this guy's going to be the row plus 1. And this guy's going to be the same row, but this is going to be column plus 1 row. And this guy's going to be the same row, but this is going to be column minus 1 and row. And so I'm going to use these 4 values to represent, to get my 4 neighbors. And I only want to load those neighbors if this guy, if it's not occupied. And also, I only want to do it if, for instance, if I'm on the top row, I don't want to look for north because there's nothing up there. I get an error, or I get an off by 1 error. And if I'm on this guy over here, I don't want to look for the east because there's nothing there. And if I'm on the very bottom row, then I don't want to look below that. I don't want to look for south. And I'm on the very first column. I don't want to look for west. And so, okay, and again, just to simplify my code, I'll go ahead and set up some local variables. I'll say this.c is equal to this.c. and I set that guy up above, and I say var r is equal to this dot r, and I've got those guys set up on top. And so oh, I did this wrong. This is cc, this is dot r, this should be an I. Okay, whoops, I. Okay, so I'm taking this guy that I'm passing in as I and j, I'm setting this guy equal to c and r down here, and then I come down here, and I'm just creating a local value c. And then one more thing I'm going to do is right in here, I'm going to simplify my code a little bit more. I'm going to go ahead and say grid, and that is going to be equal to this dot game dot grid, and I've got game.grid up above, so, or this dot game up above, so I can reach into my game object, grab the grid. And so now I'm just dealing with some simpler things. And now I want to look for north, east, south, and west. So I need to, let's go ahead and say north, east, and then I'll find south, and then I will find west. And so I have to think about this in terms of relative position. So every cell, no matter where the cell is, the guy above it is going to be in the same row, I'm sorry, in the same column, but the row is going to be -1. And so I want to say if I'm not in the top row. And so the way that I do that, if I say if row is, so I can say, I've already got row is this, so, or this dot r is equal to r. So I'll say r is greater than 0. So if r is greater than 0, then I know I'm not in the top row, and I can reach above that and find the north guy. And so I will say this dot neighbors, and I want to push into that the cell above it. Now I don't want to do it if it's occupied, but I'll go ahead and wait on that for just a minute. And so I'm going to say dot push, and I'm going to push in that cell into this guy. And so that is going to be a grid, and it's going to be in, let's see, it's going to be in the same column, but it's going to be row -1. And so that's what I'm thinking about for each of these. So let me go ahead and load all 4 of these, and we'll see how this works. Okay, so this is the basic code according to the diagram that we did back a few moments ago, where we said that I only want to look to north if I'm not on the top row. So if r is greater than 0, then get the north guy, and the north guy is going to be in the same column, but he's going to be 1 less than the row. Okay, and then for the east guy, I only want to get that if I'm not in the last column. So the last column is grid.length -1. If I'm less than that, then I want to go ahead and get the east guy. So he's going to be in the same column. I'm sorry, he's going to be in the same row, but he's going to be in the column over to the right, so C+1. And then I want to say if I'm looking for the south guy, that's going to be in, let's see, grid.c.length -1, and that means it's going to be in the, if I'm not in the bottom row, then grid.c.length -1. I might want to diagram this, but notice up here I have grid, and here I have grid C. The reason for that is that a two-dimensional array in JavaScript is an array of arrays, and each of those arrays are then in turn one-dimensional arrays of cell objects. And so I want to find the length of this guy. That's going to give me the length of the column. And so if I'm looking for the south guy, I want to find that length of the column, and I want to go 1 less than that. So if this guy is less than that, then I can find the south guy. He's going to be in the same column, but it's going to be in r+1. And then finally to west, he's going to be in the same row, but column -1. I only want to do that if column is greater than 0. So that's the first thing. The second thing is I realize I need to put in here, I only want to do this if this is not occupied. And so I'm going to say and I'll simply say this dot occupied, and I should say and not this occupied. So I don't want to fill in neighbors for the rows that are occupied, so I'll simply take this and not occupied, and I'll put it in here, and here, and here. So I have 2 conditions for each of these, and I think that's going to do it. Let's go ahead and test this and see if this works. Okay, I'm going to run this and see what happens, and it looks like I have an error, so let me hit a Control-Shift-I and come back in here. Cannot read property push. So push is the array property. So that must mean I don't have my array set up properly. So let's go back up here and see if I've got it. And I don't even have it in here. So let's go ahead and put it in here. So this dot neighbors equals an array. So I need to set that up first. So that when I'm pushing these things in, I'm pushing it into something that has been declared. Okay, let's go ahead and see if that did it. And if I run this again, okay, so that's looking pretty good. So what I need to do now is check the grid. So I'm going to say TowerGame.grid, and I'll run that, and I'll notice that I have an array of 18 elements. Each of those elements is an array of 15 elements, and each of those arrays, each of those 15 elements are cell objects. So let's think about this. If I come over, these guys have indices 0, 1, 2, 3. So let's go over 3, and then it goes down 0, 1, 2, 3, 4. So that guy should have an ID of 50. If I come over to index 3 and down index 4, so over index 3 and down index 4, that guy has an ID of 50. Good. And this guy has 4 cells. And let's see what their IDs are. It has ID 49. So 50, yep, 49 is the north guy. That looks good. And I've got ID 65. 65 is the east guy, so that looks good. I've got 2 more cells here. I've got 51. That should be the south guy right below him. And then the guy right to the other side is 35, and that guy's right here. So this guy, for 50, he's got these guys loaded in. And so, for instance, if I look over here, it's cell 64. He should have no cells. But I'm running out of time, so I'll go ahead and push on. And so I think that's going to get me started on my cell objects. The other thing I realize is that I don't want to load a cell in if it is... so for instance, I'm checking to see that this guy's not occupied before I load it, but I want to make sure I only load cells in that are not occupied into the neighbor list. I don't want to load occupied cells into the neighbor list, and so I'll make one more change over here. And I'm not sure what the best way to do this. I'm afraid if I look for it and it's not there, I can put even another if statement in here. I can just say if this guy is not occupied. Let me think about this for a minute. Okay, so this is a little bit tricky, but I'm saying, you know, if I'm not in a certain row, then I can go ahead and look for the north guy, but I don't want to do that if this is occupied. I also don't want to do that if the cell object I'm looking at is occupied. So I took this guy that I'm looking at, that's the north guy, relative to where this cell is, and I don't want to take him, so I'll say if that guy itself is not occupied. And so I'm going to do that, add this third condition. And so all 3 of these things have to be true before I can do this, and the only thing I need to do is change the coordinates of R and C. So for each of these, I simply want to take these guys, and I'm going to go ahead and paste them in here, and I'm going to take these guys and I'm going to paste them in here. And so do not add my north cell, for instance, if it's occupied, or in this case my west cell if he's occupied. Now let's go ahead and test this and see what it looks like. If I come back here and run this again, do I get any errors? Okay, I didn't get any errors. That's promising. And so the next thing I need to do is go ahead and take TowerGame.grid. So let's do that again, and we'll take a look inside here. So let's find one with neighbors. Let's find cell 80. So that's at 0, 1, 2, 3, 4, 5, 5. So I'll come in here and I'll come down to 5. And then I want to come down 0, 1, 2, 3, 4. And if I come down to this guy should have 3 neighbors, which he does. And those neighbors should be, let's see, for 80, they should be 95, 65, and 81. So there's 95, there's 81, and this last guy should be 65, and it is. So that looks like it's working out just fine. So only find neighbors for cells that are not occupied, and only find neighbors that are not themselves occupied. And so that's what we did. We now have this working, and so now what I can do is I can start down here, and I can say, I can give each of these guys values. I guess that's the last thing I'll do in this video, is I'll come over here and I'll add one more property up here, and I'm going to give each cell a value. So I'll say this dot value is equal to 5,000, some, or 50,000, some large number, and I'm going to be replacing it starting at 0 incrementally all the way back to the starting point. And so every cell will start with this value, and then I'll change them as I'm defining my path. I think that's it for tonight, so we'll go ahead and pick it up next time. We'll take a look at actually creating the number field, which will define the path, and then after that we'll do something called a vector field, and with those we're probably going to be, I don't know if this is going to be 1 or 2 more videos, but at that point we'll be able to have our enemies move along the path to find their way from the start to the goal, no matter how we set up the obstacles. Okay, that's it for tonight. Bye-bye.